So here we are. We've got the z-score for Steve listed out, and then I'm going to list out, oops, not that way, the z-score for Alana, and then we'll go find each one of them with Excel. So this is me, by the way, I am 5'9". Oopsie. So that would be 69 inches tall, minus the height for an average woman is 64 divided by 2.75 for the standard deviation. Now, we want to know what each of these numbers are, so I'm going to do that with Excel. Just grab a new page here. There we go. Now I put this in here and I typed in. So the mean for men right here, standard deviation for men, mean for women, and standard deviation for women. Matter of fact, I can put this in. Men, this is women. Okay, and then I have our particular heights. There's Steve's height at 76, my height at 69, and you can see how I did it. 5 times 12 plus 9, right? Because there's 12 inches in every foot. All right, so how about the z-scores? Now you can do this two ways. You can type equals parentheses height 76 minus 69.2, close your parentheses, divided by standard deviation. That'll work. Or you can use the function standardize. See it right there? It wants to know the score, so 76, comma, the mean 69.2, comma, standard deviation 2.9. That'll work too. Beautiful, isn't it? So either type it longhand with the parentheses and then division, or use standardize as your function. All right, and then because I used cell references for all this, I can just drag it across, and there it is for me, right? So my height, 69, minus 64, close parentheses, divided by the standard deviation. Or you can use standardize. Cool. All right, so this is for Steve. This is for Alana. There we go. So there are z-scores. Oopsie. Let me bring back that. So this one was 2.344, or 2.345, I should say. And this one is 1.818. Fabulous. All right, so who is relatively taller? Well, there's no question. Steve is not only absolutely taller, right? If he and I stand next to each other, he's taller, but he is also relatively taller. Taller, not talker. That is, he is 2.345 standard deviations above the mean height for men. And she, Lana, is only 1.818 standard deviations above the mean height for women. In other words, Steve is unusually tall, right? Because he is above 2 standard deviations away. So I better make a note of that. So note, Steve is unusually tall because he is past 2 standard deviations away from the mean. You can do it to the low side too. You can be at negative 2. All right, we have turned Alana's and Steve's heights into standard scores. So what does that mean? We eliminated the differences between men and women by paring them down to z-scores that can be directly compared, even though they're from different groups. Oops. Ah, forget it. It's 2 words. Different populations. So even though we're from different populations, by paring us down to our z-scores, we're able to actually make direct comparisons between the two of us. We're getting down to the nuts and bolts rather than worrying about his height and my height being from two different groups of male and female. So the z-scores allow us to make those direct comparisons by standardizing us, if you will.